So Jdaviz, this is an interactive visual data analysis tool for James Webb data in the Jupyter platform. Here we have a nice screenshot of what it might look like. As an overview, like I said, it's interactive. It is built on Jupyter, so you can run this in Jupyter Notebook or in Jupyter Lab, which is what we'll be using via the JWebbinar platform today. You can also run this. We basically have a command line command that you can run to open it as a browser app. And what that does is it kind of hides from you that it's in a notebook. So if you don't care about coding in notebook cells and you just want the GUI application, you can get it that way. Some nice things that building on Jupyter give us is that this lets us embed Jdaviz in websites or put it up on the cloud where you can run it on the cloud next to your data. So if you have very large data sets, it might be nice to be able to run this application and do some analysis and quick look stuff up on the web rather than downloading those large files. We hope that it's easy to install via pip. You can just pip install Jdaviz and get the latest release. You can, of course, also always go to the GitHub repository and clone that and get the latest development version. It's just not guaranteed to work as well as the released version. And what I'm going to be showing real quick here is the different preset configurations we have for different use cases. So a configuration is essentially a layout that we support for a certain use case. So first up, we have Imviz. This is for the analysis of two-dimensional images. You can see here what we call a viewer. So a viewer is kind of the main component of Jdaviz, and it's just a widget that lets you view your data. So in the case of Imviz, this is a 2D image viewer. We'll see also we have things like viewers for viewing spectrum or tables, things like that. Other things you see here up on the top, this is this app level toolbar. This is pretty much common to all of the configurations. And I'll be going through what we see up here in a little bit. In this screenshot, I have the data analysis plugins tray opened, and you can just see here we've used the aperture photometry plugin to make a little radial profile of this star that we have highlighted. Specviz is for doing analysis of single spectra or maybe small numbers of spectra. Here you can see this, we have a spectrum viewer instead of a image viewer. And you can see again, this this plugin tray is opened to the model fitting plugin. And here we have fit two Gaussians to these two emission features in our spectrum. Cubeviz, you can see this sort of combines the two we saw before. So the Cubeviz has two image viewers and one spectrum viewer. This is for the analysis of data cubes, often spectral cubes. So a three-dimensional cube where one of the axes is spectral, so wavelength, for example. And what you're seeing here, this is the flux cube. And then on the right is the uncertainty associated with that flux. And then what you're seeing below, the spectrum is not actually like a separate FITS file containing a spectrum. This is live collapsed from the full flux cube using some user-defined function. So, the default might be mean, but you could do something like max or min as well to collapse this if you would like. And you can also see here, Cubeviz kind of lets you click through in spectral space. And this indicator, this line is showing the slice that you're seeing of the cube in 2D image. Next up, we have Specviz 2D. So you can see here we have one spectrum viewer like Specviz, and then on top of that, we've added a viewer to see the 2D spectrum. So Specviz 2D lets you do things like fit a trace and background to this two-dimensional dispersed spectrum and extract from that the one-dimensional spectrum. And last but not least, we have Mosviz. So you can see here, kind of contains something that looks like Specviz 2D inside of it with the 2D and 1D spectrum, but also lets you see the direct image of the objects. And then MOS, multi-object spectroscopy. We have many objects, so you might have a couple hundred objects. And in this table viewer, you can click through the objects, and that will determine which object is getting shown in the viewers above here. I should note the screenshots were all from the Jupyter Notebook context. This is what it's going to look like today when we use it in the webinar, since this is the Jupyter Lab environment. Point out that this is what it looks like embedded on a website, in this case, MAST, the Mikulski Archive for Space Telescopes. So this is what you might see if you searched in MAST and got resulting data that was compatible for Jdaviz. You can click a button and open it right in your web browser. And then if you want to download a notebook to replicate this. So other than just looking at your data, what else do we provide? There's this concept of subsets, essentially being able to define regions of interest. So for example, if you wanted to fit a model to one particular region of a spectrum, you could select that region, and then that region would be available for you to use in the model fitting plugin. All of the viewers have the normal display options you might expect: stretch, bias, contrast, panning and zooming, all that good stuff. I already mentioned the model fitting plugin hooks into AstroPy model fitting on the back end, if any of you are familiar with AstroPy. Links to our GitHub and to the documentation. So this is basically here what the application looks like if you open it as a browser app and hide the fact that it's in a notebook. And I wanted to take just 1 or 2 minutes and show quickly some useful things. So the very first thing in the top right of all of the configurations, you can see if you hover over these buttons, they display tooltips. The 3 horizontal lines, which we call a hamburger button, clicking that opens the plugin tray. So you can see here, there are some plugins that are common to all of the configurations, for example, the plot options plugin or the subset tools plugin, and then some that are sort of more specific. So here in Specviz, you don't see, for example, the aperture photometry plugin that you might see in Imviz. Here, each viewer has its own toolbar. So here we can do things like click this zoom tool to click and drag and do a box zoom. Any of these tools that have a arrow in the bottom right corner, you can right click the tool and get more options. So for example, for zooming here, there's also an option to zoom only in the X direction. And you can always click home to go back to the original zoom. You can also pan and zoom with your mouse scroll wheel using that tool. And then most importantly, I just want to show this tool. You can see it says select a range of X values. This is for defining those subsets that I was talking about. So if I click that and I click and drag on my spectrum, you can see it highlights a region in red, and I'm going to deselect that tool just to finalize that selection. And you can see in the top left here in the app toolbar, now if I click this button, you can see there's a subset 1 here, in addition to the option to go create another one. So you can see this red color that matches up with the red color on the spectrum. If I select another one, you can see this subset is now green and is subset 2. You can always delete subsets from this list using the little trash can icon. So you can see my green subset goes away. And as I said, this is useful because these subsets can be used in plugins. So I could, for example, go into the model fitting plugin and say that I want to fit a model just to that subset 1 that I've created before. So you can also do this programmatically, which we'll see via the API, the Jdaviz API, which we'll be showing later. But I just wanted to point out where you need to click to find these things, kind of what these buttons do. I should point out for an image viewer, you can create spatial subsets. You can, for example, create a rectangular region or a circular region as well. And then I'm going to skip this button for now, but every viewer has this button all the way on the right. And this takes you to the plot options for this viewer. So I could, for example, here I can change the color of my line or something.